Humanity has spent decades looking up at the stars, but some of our greatest mysteries still lie deep beneath our feet. Welcome to the Tarim Basin in China, home to one of the most extreme engineering feats in modern history. This is Shenditake 1, an ambitious scientific exploration project designed to pierce the Earth's crust. The goal? To drill down an astonishing 10,910 meters. That is nearly 7 miles straight down, making it the deepest vertical well in Asia and the second deepest in the world. Decades ago, the Soviet Kola super deep borehole reached over 12,000 meters, but it took 20 years. Shenditake 1 aims to shatter modern records, pushing advanced technology through rock formations over 500 million years old. The mission is twofold: groundbreaking geological research and the hunt for ultra-deep oil and gas reserves previously thought inaccessible. But to reach these forbidden depths, engineers will have to overcome extreme heat, crushing pressure, and the limits of human endurance.
This is the story of how they built the impossible.
Before the first inch of dirt could be moved, the team had to conquer the Taklamakan Desert itself.
Thousands of tons of equipment had to be transported through one of the harshest environments on Earth.
The mission is twofold: groundbreaking geological research and the hunt for ultra-deep oil and gas reserves previously thought inaccessible. Surveyors mapped the exact coordinates in the Tarim Basin, targeting a specific deep earth fault line.
Massive foundations were poured to support the weight of the gargantuan automated drilling rig.
This wasn't a standard oil rig. This was a custom-built, automated behemoth designed to handle 12,000 meters of pipe. Every bolt, every weld had to be flawless to withstand the immense torsional forces of deep earth drilling.
State-of-the-art automated control systems were integrated to manage the unprecedented depth. The rig towered over the desert floor, a true marvel of modern engineering.
By May 2023, the stage was set, and the massive drill bit was locked into place. On May 30th, the order was given to spud the well. The giant bit made contact with the earth, biting into the desert crust. The journey to the center of the Tarim Basin had officially begun. To keep the drill bit cool, thousands of gallons of specialized drilling mud were pumped down the hole. This mud not only cooled the bit, but carried the crushed rock back to the surface for analysis. Even in the early stages, geologists monitored every inch of rock returning from the deep. As the hole grew deeper, new 30-foot sections of steel pipe had to be continuously added. Automated systems handled the back-breaking work, spinning the heavy steel with perfect precision. Drilling operations continued 24 hours a day, 7 days a week, with no pause.
The sheer energy required to spin thousands of meters of steel pipe was staggering.
Massive generators roared non-stop to power the automated rig and massive mud pumps.
Through the summer of 2023, the drill bit chewed through the softer upper sedimentary layers. The drillers carefully controlled the weight on the bit, ensuring a perfectly straight vertical trajectory.
Even the slightest deviation could cause catastrophic friction at extreme depths.
Mile by mile, the steel string grew longer, heavier, and more difficult to control.
The Tarim Basin is a geological puzzle filled with unpredictable rock formations. As they hit harder rock, the drill bits wore down rapidly and had to be replaced.
Pulling miles of pipe out of the hole just to change a bit took hours of grueling, precise labor. The deeper they went, the more punishing the environment became for the equipment. Every connection had to be perfectly lubricated and torqued to prevent a disastrous snap. With a fresh bit attached, the long journey back to the bottom commenced. Passing the 3-mile mark, the team entered uncharted geological territory.
Suddenly, the downhole pressure began to rise dramatically. They had hit a high-pressure pocket of ancient, trapped gas.
To hold back the crushing earth pressure, engineers increased the density of the drilling mud. The massive blowout preventers stood by, ready to seal the well instantly if the pressure broke containment. This heavy fluid acted as a liquid plug, balancing the immense forces miles below.
Crisis averted, the bit continued its relentless downward grind.
But above ground, the Taklamakan Desert unleashed its fury.
Massive sandstorms battered the structure, testing the resilience of the engineering.
Yet, the automated rig was designed to withstand the worst of nature, and drilling never stopped.
As the well deepened past 6,000 meters, a new enemy emerged: heat.
The deeper into the Earth's crust they pushed, the hotter the surrounding rock became. The returning drilling mud was quite literally boiling hot.
Standard electronics and rubber seals simply melted under these extreme conditions.
These custom tools were designed to survive the deep earth furnace.
China National Petroleum Corporation had to deploy newly developed, high-temperature resistant technology.
They were lowering equipment into a zone hotter than most commercial ovens. Despite the heat, the sensors transmitted vital data back to the surface, mapping the rock formations. The sheer weight of the drill string was now equivalent to a small skyscraper hanging from the derrick. The strain on the hoisting equipment was absolute. One snap could mean losing the entire well.
By late 2023, Shenditake 1 had passed the 8,000-meter mark.
Friction was immense. The bit was grinding through incredibly dense, igneous rock. To understand this ancient world, geologists ordered deep earth core samples. Coring at these depths had never been attempted onshore in Asia. The prize, solid rock that had not seen the light of day for over 500 million years. These ancient stones held the secrets of the Earth's continental shifts and deep energy reserves.
But the final stretch would prove to be the most agonizing and dangerous.
Pressures at the bottom exceeded 145 megapascals, enough to crush a submarine like a tin can. The rock formations were highly unpredictable, alternating between hard stone and fragile, fractured shale. The risk of the wellbore collapsing inward and trapping the drill string was terrifyingly high.
To secure the hole, massive steel casing had to be cemented into place.
This would become the world's deepest liner cementing operation. The cement had to cure perfectly in temperatures exceeding 200 degrees Celsius. Against all odds, the casing held, locking the deep earth out and keeping the wellbore open. As winter set in, the surface temperatures plummeted, while the bottom of the hole grew hotter.
The crew battled extreme temperature fluctuations, enduring freezing winds above and boiling mud below.
Then, after hundreds of days of relentless drilling, a monumental milestone was reached. 10,000 meters. The magic number.
Shenditake 1 had become the fastest onshore well in history to exceed 10,000 meters.
But they weren't done yet. The ultimate target was still 910 meters further down.
The final 910 meters would prove to be the most grueling phase of the entire project.
In the ultra-deep zone, drill bits were destroyed in a matter of hours by the ultra-hard rock.
Progress slowed to a crawl. Tripping the massive drill string took up most of the time.
Temperatures soared well over 200 degrees Celsius, pushing the absolute limits of material science.
Every fluid, every tool, every piece of steel was operating at the edge of failure. It took nearly 300 days just to conquer these final 910 meters. The rock at this depth was so compressed, it behaved differently than anything near the surface. They conducted the world's deepest wireline imaging logging to map this alien environment. The imaging revealed massive, deep-seated fault lines and ancient geological structures. They had made the world's first onshore oil and gas discovery below 10,000 meters.
The project had successfully confirmed the existence of ultra-deep hydrocarbon resources.
As February 2025 approached, the final target depth was in sight. The culmination of over 580 days of grueling, relentless work. 10,910 meters, total depth reached.
In February 2025, Shenditake 1 officially became the deepest vertical well in Asia. It was a monumental victory for engineering, geology, and human perseverance.
The well was secured, completing a staggering profile of the Earth's crust. It passed through 12 distinct geological formations, acting as a deep Earth laboratory. Shenditake 1 pushed the boundaries of what is possible, proving that no depth is truly out of reach. The technology developed here will pave the way for the future of deep Earth exploration. Automated rigs capable of 12,000-meter depths are no longer just theory. They are reality. The data collected from the sonic logging and rock cores will be studied for decades, providing unprecedented insights into the tectonic history of the Asian continent.
As the massive rig is eventually disassembled, its legacy remains permanently etched into the Earth.
The project matches the significance of deep-sea exploration and space missions.
It proved that humanity can engineer solutions to overcome crushing pressure and boiling heat.
And it opened a new frontier for global energy security.
The sheer logistics of maintaining this operation in the Sea of Death is a marvel of its own.
It required the relentless dedication of thousands of engineers, drillers, and scientists.
A tiny steel cap on the surface is all that remains of the deepest hole in Asia. Beneath it lies a tunnel that pierces halfway through the Earth's continental crust. monument to human curiosity and the drive to explore the unknown. Shenditake 1 is more than just an oil well. It is a scientific triumph. A testament to what can be achieved when cutting-edge technology meets sheer human willpower. The men who built it have written their names into the history of deep Earth exploration. As the world looks for new sources of energy and knowledge. Shenditake 1 stands as a beacon of modern engineering. The journey to the center of the Earth has only just begun.
The deep Earth awaits.